Howdy again, it's Mr. Pete, your internet shop teacher, and welcome back to my shop. And this is tips number 869, which is part 2 of a two-part video. Make sure that you watch part 1, and here is what the title looks like right now. So I hope you have watched that video so you understand what I'm doing, but I am making a push-button type quill stop for the Bridgeport mill, and in part 1 I made the nut, which looks like this. Pretty simple, but you better follow the instructions if you want to do that. You can buy one of these commercially for about 50 bucks, which is a wise decision. It's kind of a difficult one to make, but in this part I will be making the main body. Remember, it consists of the body, the nut, and the spring, which just dropped on the floor and I will never find. So let's get started. Okay, here's the part we are making today. Fairly difficult to make, so I want to give you some dimensions should anyone ever want to do this. There is no drawing, there are no blueprints, so I'm going to give you a living blueprint right now. First of all, it's made out of 1.5" round stock. And this is the stress proof that I got. They're Caterpillar drop-offs. So try to use something that is fairly free machining because of the knurl, which is difficult for everyone. So the overall length of this is just under 1.5 inches. Matter of fact, you probably could make it 1.5 inches, and the body itself is 1 inch, which leaves you approximately 7/16 right here. And the diameter here is around 685, and the hole here is 1/2. You do not need to ream it, drilling is good enough. And this hole is 5/8, and it doesn't go quite all the way through. Now I'm going to knurl about 1.5 inches, and later on it is turned down smooth here so that the graduations can be put on, and a little undercut here which just makes it look better, I think. Before we get over to the lathe, let me just explain a few things. This is the knurler that I will be using. It's a Brown & Sharp. You've seen me use it in other videos, and the maximum capacity of this is 1.5 inches, and believe me, it barely fits in there. And the length of the knurl cannot be very long because of the diameter of this hole. So the very first thing that I'm going to do is, and the order of operations is pretty important here, I will be turning this down to diameter and knurling from this end, and that allows this diameter here to go into the hole, and that is about the maximum depth that I can achieve with this diameter stock and so on. And that's why I'm not doing it in this direction, because I want to this is my handle. I'm not going to cut this off until I'm done with all of the operations. Matter of fact, that'll be the last thing I do. Again, order of operations is pretty important. You might be able to vary a little bit from what I'm telling you now, but I've already experimented, so just take my word for it. The work is chucked up on the closing lathe, and I have a starter drill, center drill, and then I'll drill 1/4 inch and 1/2 inch to a depth of about 1 3/4. You're better off being a little bit deeper than shallow for when you cut it off. Next, I will be turning down this diameter, and that is 11/16 in diameter, which is 0.687, and 7/16 long, and I have a carriage stop set for that. And have you noticed that lately I've been using the diamond tool holder here, and I really do like that. Gives you a nice square shoulder, and I've been promising a video on that for a long time, and it still is coming up. It's on the back burner. Okay, it's turned down to diameter and length and drilled 1/2, and now I'm ready to put the knurl on. Always a tricky part, so let me go ahead and set up that Brown & Sharp knurler, and we'll do that real quickly because you've seen that in many other videos. I'm all set up to knurl. I'm at slow speed back gears. I will be using power feed, and remember that I can only go in here up to this point here. So I have about 1 inch at the most of knurl that I can make before I bottom out. I do not want to bottom out under power feed. Lots of oil. You know what? I've been bragging up this Brown & Sharp knurler, and I got a perfect knurl here, but this one is not perfect, and I'm surprised. The problem I'm having with this is that I'm at the very end of the travel here, and I have really no adjustment, and these little adjusters, in fact, are kind of wobbly when they're all the way out, so that's what I'm troubled with here, but it's going to have to do because I'm not going to do it over. So let me take it out, and we'll step over to the milling machine and put that cross hole in there, and that's pretty tricky, but let's step over to the bench, and I want to explain something before I do that. Alright, I'm going to step over to the milling machine here presently and drill this cross hole, and that's a 5/8 hole, and it is a blind hole. Be careful you do not drill too deep like I did on this sample and it started to break out. So that's one thing to be careful of. And the other is that this is 1 inch from the end, the center of this hole, 1 inch from the end. And of course we're going to center it this way. And this is 1.5 inches, so I'll use the DRO and I won't show all of that. I will be using an edge finder to locate that. Then I will pilot drill it, and I want a flat bottom hole. So I can't use a regular 5/8 twist drill. I want to use a end mill, and that'll give me a flat bottom hole and an accurately sized hole for that matter. So it's going to go in there like this all the way to the bottom, but I will have a large hole pre-drilled, so I'll just be cleaning up with this. But now I want to give you a warning, and this isn't going to happen to you, but I always tell you to double check your sizes and blah 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 like that, and I drive you nuts, I'm sure. So I grabbed this end mill of mine, and what size is it? 5/8. So with the original, I think it's this one, yeah, in I went, and it's just fine. That's a week ago. And when I got over to the bench here, what would happen is that this 5/8 would not fit in there. It wasn't even close. But I thought, well, I'm just 1/1000th or 2 off. So out came the reamers. Now the trouble with reaming a blind hole is that, remember, on a hand reamer like this, we've got, I don't know, maybe a ½ inch or even more of tapered flutes on the end to help you get started. So you can't use a hand reamer if you want the hole accurately sized all the way to the bottom. So I pulled out a power reamer, and that wouldn't do me much good either, because there's a chamfer on here. But the real problem here is, and I couldn't get this to start. I thought, what the heck, I'm only taking off a couple thousand. So to get to the bottom of it, and I wasted a lot of time, same as I'm wasting time talking. But what was the problem? Okay, this 5/8 end mill is not 5/8. I finally mic'd it. I don't know why it is undersized. It does not appear to have ever been reground. Possibly it was a reject. I don't know where I got it. And the reason that I was using this particular one is because I get lazy in changing collets. So this is a ½ inch shank, supposedly 5/8 on this end. That's why I used this one. But I had to go back and redo another one with a real 5/8, and I did measure this, but this is a 5/8 end mill with a 5/8, truly a 5/8 shank. So, I'm warning you here to check sizes. Okie doke. The work is mounted in the 6-inch Bridgeport vise setting on parallels. Notice that it is setting outboard, that is, the knurl is not being held in the vise because the vise jaws would crush and leave a mark on the knurl, I'm sure. Now I've already used the edge finder here and found the middle this way. 1.5 inch stock, so half of that is 750 thousandths, and then I used the edge finder from the end here, and I moved in exactly 1 inch from this end. And I'm going to center drill right now and prepare to drill and bore. Next, I'm ready to drill the pilot size 1/4 inch almost all the way through. Now here is the way I am checking the depth. There'd be an awful lot of different ways of doing that, but here is a planer gauge setting on a parallel, and I have set the planer gauge Starrett brand such that it's 1/8 of an inch up from the bottom, and I used a 1/8 inch drill bit to space that out. Do you understand what I'm doing? And then, moving it out like this, I can bring my drill bit down, and I'll do the same thing with these other bits, but I won't show that. Touch the planer gauge like that, and you can't see what I'm doing now, but with my left hand, I am putting the stop up here on the quills for the quill stop. Chatty Cathy. Listen carefully as the quill stop makes a little bit of a sound. I'm bringing it down. And so there's my depth. And since I have a digital readout, I can crank the table right back into position. And I'm ready to drill. And let's drill the 1/4 inch pilot. Next, I'm drilling 19/32. Now that's 1/32 smaller than 5/8. I'm in back gears, and I'm going to press rather lightly because I do not want the work to tilt in the vise. I could put a jack stand under here, but the bolt's in the way down here. So that is the next step. Again, I don't want to go all the way through, so I have checked the depth with that planer gauge. I will also do that with the final cutter. I won't even mention that. Almost all the way to the bottom. This is the 5/8 end mill. That's going to give me a flat bottom hole. You can of course use a boring bar if you want. It would take a lot of extra time, but that'll give you a flat bottom hole. If you have bottoming drills in larger sizes like a 5/8, you can use that, but raise your hand if you have a flat bottom 5/8. I didn't see a single hand go up. Now, I'm probably making too big a deal about a flat bottom hole because I wanted it flat simply because that is where the spring is going to lie, and I want as much room for the spring as possible. And if we use a regular 118 degree, you can imagine that we're losing a little space. So that's the whole reason I'm making such a big deal over this. And there we go, double check. Oh, I drilled all the way through. Just kidding. Actually, I'm not quite to the bottom of the hole because there are chips that fell in there and have packed. So I'm going to clean that. I can't really get in that direction, but I want to get all the chips out of there. And I will turn this so that it's 7/16 back from my finger up into the knurl, and I have set my carriage stop for that. I love a carriage stop. Can you hear it? And I'll take off just enough to remove the knurl. And finally, I want to turn this little step right here. Did you know that the Diamond Tool Company makes a right and a left-hander? So I'm going to take this tool out and put this tool in and turn it down right there just a little bit, and then it's ready to cut off. Okay, out it comes, and over to the bandsaw I go, and I'll cut it off, leaving a little bit to clean it up. Cut it off with a cutoff tool if you prefer, should you make one of these. And this is the waste stock, this is the handle. Throw it away when you're done. Don't let your scrap pile get too large, it'll only burden you. Okay, I cut it off. You know, I didn't drill any too deep, did I? So now I will hold it by this. I don't want to hold it by the knurl. I suppose I could hold it right here. And I will face this off to length. Not very critical at all. And I want to deburr this. I've already run the reamer, 5/8 reamer through there to clean that up. And I'll use the old Noga here a little bit. But I'll probably have to use a file more than the Noga over the knurl. Alright, let's get back to the mill, to the lathe real quickly. Is everybody happy? Is anyone actually watching it at this point? If you are still watching, leave a comment so I know. Okay, here's the setup. Now, I'm gripping it in the 3-jaw chuck by this, and I'm afraid since this is rough cut, it's not square, you know, it's wobbling, maybe you can see that. So when I take the first cuts, I don't want it to fly out of there and bend this, and I'd end up pouting and in bed the rest of the day. So I just ran this live center up against there to hold that in place so nothing can happen. And then at the very end, I'll back that off and just take 2 or 3 thousandths off, and that will finish the job, and I won't show all of that. Wow, I need to sharpen that tool, but you know, I hate to stop in the middle of a project and sharpen a tool, don't you? Well, the next job here is I have to put a radius on the end of this nut. How am I going to do that, you ask? Well, first of all, why don't I go ahead and make sure this fits. So I'll drop the spring. I'm going to talk more about the spring in a minute. Get in there. All right. I made this. This is half 13. You know, it's hard to find, or half 20. It's hard to find fine bolts, or at least I don't have many. So there it is, but that's uglier than heck. Plus, it wouldn't have the clearance. It has to be almost flush, and you'll see why later when we go to install it. So how am I going to put the radius on? So this is one of my original prototypes where I was just measuring the holes, and I did all that work for you. So I'll put the spring in there, and I'm going to put this in, the nut, half nut, and take this commercially made bolt and I'll run that up. And matter of fact, I'm going to tighten this with a wrench, and you'll see why. I keep telling you, you can see why in the future. I guess I'm trying to avoid telling you. So tighten this. Now I'm going to put this in the 3-jaw chuck on the lathe and simply turn this down. And that will give me the radius. Pretty neat, huh? Now you, as I said, you might have to make up something to hold this. I wouldn't want you to hold it in this and damage it, because, you know, I've got a lot of time in this already. And with filming it, it takes about 3 times as long, maybe 4 times as long, plus all the prototypes. So it's a lengthy thing, plus this video is long, isn't it? Way too long. It should have been a 3-parter. Okay, here's the setup, and I'm using the diamond, or rather dull tool. At the moment, this is an interrupted cut, as you can see, so there'll be a tendency for maybe this to bounce around, even though I've got the bolt pretty tight, but I don't expect a great finish because I had trouble on the prototype. But let's make some chips and quit talking. And you can see the radius forming, can't you? I'll finish it off, and I'm going to come down to a small enough diameter where I'm actually skimming the aluminum just a little bit. Come on out of there. Little deburring and we're done. Let's talk about springs again. Now, you're probably better off going to Ace Hardware, even if you got to drive 50 miles, rather than sort through 3 drawers of springs, but that's what I did. And this is the approximate size spring that you need, a compression spring. It doesn't need to be very long. It needs to be anywhere between 1/2 and 5/8 diameter. That isn't too critical at all, because that is the one that I've been using, and you will clip them to length. You're probably not going to have a short one like that. You don't want it too strong and you don't want it too weak. You want it just right. Well, what's the diameter of the wire? It's about 40 thousandths. So I will clip this off with the Bernards, and that will be my new spring. I always clip them extra long and then go back and clip some off if needed till you get the right amount of pressure on it. Well, drum roll please. And I like to put the cut end down in there first, and then the half nut. And it's almost flush, and it looks good, and it works. So this is done, except for the graduations. Now what I'm going to do next, and finally in this video, is install this. And I may not show how to install it. I'll just come back with it installed because the video is running so terribly long. And again, there are no graduations. I may put graduations on there if 15 or 20,000 people watch this series of videos. If they don't, there really isn't enough interest to bother doing that. And it would be graduations, something like this, that would be put on, and those are simply scribed into place using a dividing head or a rotary table or something like that. And that's not so hard to do. The hard part is to put and stamp your numbers on there straight so they look good, and that's not easy on a cylinder. And that's why I'm kind of shying away from that at this time. And the graduations on here would run from 0 to 50 thousandths, not 100 thousandths, because the screw is 20 threads per inch. Okay, now to install it, and in order to do that I have to remove this screw, and there's a retaining ring and some other little parts that I have to remove in order to do that. I'll clean it up real good, and then I'll take this wheel and this wheel off and put them in storage and mark them, because at some point they may go back on by the new owner. So now the screw is loose and ready to take out, other than to spin these nuts off, and this is the whole reason for using one of these or the other type that I have shown you, because this is like the world's biggest nightmare. I need anyone that likes this system to leave me a comment, because you would have to be at least mildly mentally ill, and look at how long it's taking me to screw these clear off of this thread. So I'll do that off camera so you don't have to suffer with it, and this is my last time of suffering with it. Sorry for the rant. No, I'm not. Okay, that took forever to spin that nightmare off. Glad to get this thing out of here. Now, one thing that I had to do here in rework is the diameter right here. I had to reduce to 660 thousandths. I just dropped that spring. I hope I can find it. Yeah, I see it down there with the ladybugs. Anyway, this wouldn't quite fit into this. So down it came, and now if I can find the spring, I will reassemble this. And I did find it. Nothing worse than dropping a spring, is there? Now make sure that this button here is flush or below, or you will run into clearance problems here with this little ruler. So let's put her in place there and see if I can get it in. And there it is. Now off camera I'm going to go ahead and reassemble this. It's kind of tricky. If you have never done this and can't figure it out, that is a potential video that I could make, although I don't know how many people would watch it, but it's kind of tricky. I'll put that together again, as I said, off camera. Okay, it's totally assembled without a hitch, and look at how it works. We can merely push the button, raise it and lower it. Sometimes it takes two hands. And when you plunge cut, there's your stop. Now if you want it more accurate than every thread, which is 20 thousandths, of course you're going to have to turn this. By the way, notice how little clearance there is right here between the button and the ruler, so that must be flush. Put a little oil on here. This thread was very, very dirty, but I can easily move it up and down. I love it. No more of this craziness. I am, however, missing the graduations right here, which could be potentially another video, but I kind of doubt it. You know that 1/2 of a turn would be 10 thousandths, so you can kind of guesstimate. And there it is. This will take a lot of frustration out of using the quill on this machine, won't it? I hope you can make one or buy one. As I said, look at the clearance here. I got a close-up. Now if that would bother you too bad, you could take the ruler off and trim it a little bit on the mill, maybe take 10 thousandths off or whatever. It wouldn't make any difference at all. Leave a comment if you liked the video. Make one if you feel like it. It was a fun project, but I'll have to tell you that it isn't particularly easy, and you need an awful lot of equipment and tools in order to make it. And there's just a small sample of what I used during the milling operation. And many more things on the bench, and I have a big cleanup job to do. Now what I'll do with this is put a wire tie through there and a little tag, and then put it in this. I love this cast iron secret drawer, don't you? And I'll put it right in there with a few other accessories that I never use, including an extra drawbar and wrenches and whatnot. In later models they cheapened this and did not make a cast iron door. Isn't it? It's cast iron, not plastic. And as always, please give me a thumbs up if I deserve it, and some comments. That all helps with the algorithms, whatever they happen to be. And there we go. That's the biggest improvement I think I've ever made on this machine. Love it. Push button, quick acting, depth stop for the quill. See you next time. Just a short addendum here. If you don't feel like making one of these, make the pinch type. And remember, there's a two-part video for that, and I'll put the link in the description. It's a little easier to make, and it works just as well. However, you do not have the ability to move in just a few thousandths by rotating this. You can only move this every 20 thousandths on this screw. And by the way, I think maybe I told you that I had to clean the screw and lubricate it, and everything now works perfectly. End of addendum. And stay tuned for a host of still pictures.